Hi, today we are going to introduce you how an interference is happening. So first of all, in order to keep an interference pattern, we take two bulbs, two illuminating sources separately, S1 and S2, bulb B1 and B2. We know that this interference will not this will not give you an interference pattern. The intensity is just add up, so you will get intensity as I is equal to 2I0. So there is no interference pattern. So Young's a scientist named Thomas Young just overcome this difficult to get a constant phase, or the light source with a constant phase. The phase of the light source will not change with the time, that is a constant phase. So this will happen only if we take a single source and we illuminate two pinholes S1 and S2. So we assume that in figure 12a we take a light source, and after a distance, means just from this light source a distance, small distance apart, we kept another opaque screen and we made two pinholes S1 and S2, so that it act as the coherent sources, or the sources with the phase that do not change with the time. So this will give you an interference pattern on the screen. That is what you can see in the Young's double slit experiment. So in this diagram, what we are observing is, what we take is S1 and S2 are the pinholes or the sources, and these are also separated, these two sources separated by a distance d, and from this sources at a distance d from the source we kept a screen, and on the screen you can see the interference pattern. Let us assume let us take a arbitrary point p where we can see an interference pattern. So we just assume that it is at a distance x from the perpendicular bisector o on the screen that touches the point O on the screen. So O to P is x distance, and the screen can be named as G dash, and this can be taken as the x and z axis of the screen. Then we assume S2P minus S1P is equal to n lambda, where n is equal to 0, 1, 2, 3, etc. You can take here for starting with the left hand side, we can take S2P whole square minus S1P whole square. Here we can consider two right angle triangles in the diagram, so that S2P can be considered as the base of the triangle, one triangle, and S1P is the base of the second triangle. So you can say that this distance is equal to S2P whole square plus d square plus x plus d whole square is equal to d square plus x minus d by 2 whole square. So we can expand these terms in terms of a plus b whole square, and there are common terms like d square, x square, d square by 4, all the square terms, and there is a negative sign, so this will repeat, and there is a negative sign, they will cancel each other. So the remaining time is xd and plus xd, so you will get a 2xd term. So S2P minus S1P into S2P plus S1P is S2P square minus S1P square. That means a square minus b square is equal to a minus b into a plus b. So you can just write S2P minus S1P is equal to 2xd by S2P plus S1P. So this is given in the equation. So in this equation, S2p plus S1p is equal to 2d. You can directly assume that this is the distance when you get when we consider a small when we neglect the small d in terms of this one. So if you assume this is very small, you can say that this is approximately 2d distance. If the separation is very small, you can just easily assume that this is 2d distance. So S2p plus S1p is 2d. So you can substitute in this equation. S2p plus S1p is equal to 2d. 2 cancels and you will get xd by d. So S2p minus S1p is equal to xd by d. Here this S2p minus S1p is the path difference. So this left hand side you can write n lambda or n plus half into lambda. So x can be termed as accordingly, whether it is bright or dark. You can write this one as n lambda or n plus half lambda. So if it is a constructive interference is happening, the region will show as a bright spot. So you can say that it is a bright region. So you can say that x equal to xn is equal to n lambda d by d. And if it is a dark region, if it is a destructive interference is happening there, means it is a dark region. So you can say that x equal to xn is equal to n plus half into lambda d by d. So you will get these two values. Then we assume that this pattern, first a bright region, then a dark region, after that a bright region and a dark region, this will repeat and you will get it as a pattern. So the distance between, when we consider this distance is equal, you can say that the distance between two consecutive dark and bright region is remains the same. So this seems as a fringe pattern. So this is called a fringe, and the distance between two consecutive pattern as a, this is distance is beta is equal to xn plus 1 minus xn. So you can substitute n as n plus 1 and n plus 1 lambda d by d. This is beta is equal to lambda d by d.